This is part 2 of section 5.5, and we have our first system of inequalities. Now, both of these are linear, and so this is a system of linear inequalities. We have to graph both of them on the same coordinate system, and our answer is going to be the region that is included in both. So basically you can think of this as we graph both of them, and then whatever area is shaded by both, that's going to be our answer. So we just need to get these things graphed. So I'm going to start off with the top one, and I have x minus y is equal to 4. Okay, so we just need to get this graphed. You can rearrange this, put it in slope-intercept form if you want to. You can use intercepts, just whatever you need to do to get it graphed. So I'm just going to use intercepts. If x is 0, that means I have negative y is equal to 4, so y equals negative 4. That gives me the point 0, negative 4, 0, negative 4. Okay, and then if y is 0, then I have x minus 0 equals 4. So that would be the point 4, 0. Okay, so I know where my boundary line is. I just need to decide if it's going to be dotted or solid. And if you look up here, it has an equal to on it, so it's going to be solid. Okay. Okay, let's get this thing, let's see if I can get it graphed nicely. Okay, so we have this line. Now we need to figure out which side of this to shade. 0, 0 is available, so I'm going to test 0, 0 and see what happens. Okay, so I'll have 0 minus 0 is greater than or equal to 4. 0 is greater than or equal to 4, which is false. Okay, now what's going to be slightly different whenever I have a system is I'm going to figure out which side to shade, but I'm not going to do it in the very beginning because I'm really interested in where they overlap. And I don't want a lot of excess noise on my page. So I'm going to do a little mark here. Okay, so I tested 0, 0. It's false. So that means this side must be shaded. Okay, now instead of actually shading it and making it difficult to see where my answer really is, I'm just going to make a little mark right here, a little arrow. I've done my thinking. I know I'm supposed to shade this side of the line, and I've done the thinking. I just haven't done the scribble yet. That's all that's missing right now. Okay, now let's do this one. So I would pretend that I have x plus y is equal to 6. Now I can easily use intercepts again. So if my x is 0, that means I have y equal to 6, so that's the point 0, 6. Okay, so if I have 0, 6, it's up here. Okay, so if I have y equal to 0, then I have x equals 6, so that's the point 6, 0. 1, 2, 3, 4, 5. Okay, now is this a dotted line or solid line? It has an equal to on it, so it's solid. Okay, so here we go. Now I need to figure out which side of this I'm going to shade. And I can use 0, 0 again. And so I take 0, 0 and plug it in up here. That would give me 0 plus 0 is less than or equal to 6. 0 is less than or equal to 6, which is true. So what's going on here, I'm looking at this pink line right here. 0, 0 is right here. I plugged it in and it was true. So that means I'm shading this side of this line. So again, I'm just going to draw myself a little arrow right here. Now our answer The answer is the overlap, okay? Now, what you can do, and this may help later on in some of our more difficult problems coming up, is use something to cover up the parts that are not right, okay? So, like right here, I'm shading this side of this line, so I'm going to use an index card and cover up the part that's not true, okay? Now I have my arrows placed a little bit weird, and so I'm going to double up this. I'm shading here, so I'm going to put a little mark down here. And the reason I'm doing that is because when you start covering things up, I've covered up my arrow here. So this side is not part of your solution. This side is not part of this solution. So if you cover them both up, where's your answer? Right here. Okay. If you're doing this on paper, one of the things you would want to be careful about is making sure this little triangle right up here gets shaded, because a lot of people, they just leave off that little part and it can cause major problems in different types of problems later on in math. Okay, so this is our complete answer. All right, so let's try another one. I want to solve this system. Okay, so first thing I do, I notice real quick, I just do a quick overview. These are both going to be lines because I don't have any exponents. One of these is a solid line, one of these is a dotted line. So that's something that's very easy to mess up just by carelessness. So the sooner I make a note in my mind that that's what's going to happen, the more likely it is that I'm going to remember that I have one of each. Okay? So let's start with this one. I pretend that I have 2x minus y is equal to 4. Okay, so let's try intercepts. If x equals 0, then what I end up with is 2 times 0, which is 0, minus y is equal to 4. So y is equal to negative 4. That would be the point 0, negative 4. 0, negative 4 would be down here. Okay. So now I have the point y equal to 0. And that will, if I test y equals 0, then I get 2x is equal to 4. Divide both sides by 2, and x equals 2. Therefore, I have the point 2, 0. 2, 0 is right here. Now I'm graphing this one, and it has an equal to on it, so this one's solid. So I'm going to connect these 2 points with a nice solid line. Okay, now again I need to figure out which side of this to shade. Since my line does not go through 0, I'm going to test the point 0, 0. We're still on our first one. 2 times 0 is 0. Minus 0 is less than or equal to 4. So 0 is less than or equal to 4, which is true. So for this line, here's 0, 0, and it was true, so this whole side is true. I'm going to mark my arrows here, and I went ahead and marked it in both locations so that I don't have the problem I did above where I ended up covering up one of my arrows. Okay? Now let's go with this one. Okay, so that I pretend that I have 3x plus 2y is equal to negative 6. This is fairly easy to use intercepts for again. So I have x equals 0. If x is 0, then I have 3 times 0, which is 0, plus 2y is equal to negative 6. Divide both sides by 2. So y equals negative 3. So that means I have the point 0, negative 3. 0, negative 3, which is right there. Now let's use y equals 0. That will give me 3x plus 2 times 0, which is 0, is equal to negative 6. Divide both sides by 3, and you get negative 2. So that gives me the point negative 2, 0. Negative 2, 0 is right here. This only has a greater than, no equal to on it, so we use a dotted line. Okay, so I'm going to draw this one in as a dotted line. Okay. Now, I don't believe the computer makes you do this, but I'm going to go ahead and make a point. Technically speaking, you know, this line, every single point on this line is part of the solution. None of the points on this line are a solution. So technically, no matter which of these parts I shade, where these two lines intersect is not part of the solution, and you should put a little open circle there. This is the equivalent of having a hole in a rational function graph. Okay, this point right here, since it's not included, it is included in this one, but this one takes precedence. If it's not part of this one, it's not part of the overall solution. Okay, so this is mainly, since I don't believe the computer makes you do it, this is more for those of you who are going on to pre-cal or calculus and so on. Okay, so let's test 0, 0. It's not on this boundary, so again, I'm going to test 0, 0. That gives me 3 times 0 is 0, plus 2 times 0, which is 0, is greater than negative 6. 0 is greater than negative 6. Now, I see a lot of people make stupid mistakes right here. It's like the negative completely throws this off. But if you slow yourself down a little bit and really think about these, I mean, it's not that difficult. It's just very easy to make a stupid mistake here. 0 is bigger than any negative number, so this is true. Okay, so on the dotted line, our true side is, was it what we tested, it was true, so this whole side of this is true. So I'd shade this side and this side. Now let's try using our, I'm going to cover up the index cards, and we use index cards again to cover up the part that's not right. I'm shading this side of this line, so I'm not shading here. Shading this side, so I'm not shading here. It makes it very easy to see what part's left, what would be our overall solution. And then we shade the overlap. And we have the answer to the entire system of linear inequalities.